All right, dude, let's like crack open this quantum computing thing.
It's pretty wild, right?
It is. It's like, whoa, dude, the future's like knocking.
Yeah.
And it's wearing a lab coat and holding a Quibbit or something.
It's definitely got that vibe.
Yeah.
We've got this Google blog post about their new Willow chip.
Okay.
And then like some hardcore analysis breaking down what it all means.
Nice.
So get ready to have your mind melted.
Yeah.
We're going deep.
Deep, man. Like Mariana Trench, deep.
There you go.
So Google's all hyped about this Willow thing.
Yeah.
Saying it did something in 5 minutes that would take a supercomputer 10 septillion years.
Yeah, it's a lot of years.
10 septillion. That's like more years than there are stars in the sky, right?
It's a big number.
Yeah.
But basically what they're claiming is a massive speed up for a very specific task.
Okay.
Called random circuit sampling.
Random circuit sampling.
Which is basically a test to see if a quantum computer is, well, actually quantum.
So like a quantum test for quantumness?
Kind of, yeah.
Dude, that's like totally meta.
Think of it like this. Imagine trying to simulate a laser beam passing through an ice cube.
Okay, I'm picturing it.
All right.
Sparkly lasers melting ice.
Yeah.
It's trippy, man.
So for a regular computer, predicting that light scatters is insanely hard.
Okay.
Because of all the quantum weirdness going on at the atomic level.
Right.
But quantum computers are built to handle that kind of complexity. So this random circuit sampling is like testing if Willow can swim in those quantum waters.
So they're judging this quantum computer based on how well it mimics the quantum world.
Pretty much, yeah.
It's like judging a fish by how well it swims, man.
Exactly. It's a bit circular, but
Yeah.
the point is to see if the tech is doing what it's supposed to.
Right.
And not just that, but scaling up without too much noise.
Noise. Like static on the quantum radio?
Noise is like errors.
Oh, okay.
The Achilles heel of quantum computing, the
Okay.
more qubits you add, the more likely things are to get messed up. It's like juggling, you know? The more balls you add, the harder it gets.
Whoa, that's deep, man.
So is this Willow chip just a really good quantum juggler?
Is it?
That's what Google's claiming. They're saying Willow is below threshold.
Below threshold.
Which is a huge deal in the quantum world.
Dude, that sounds kind of ominous.
Oh, yeah.
Like crossing the threshold of reality or something?
It's actually the opposite.
Okay.
Below threshold means that as Willow gets more qubits, its error rate actually goes down.
Wait, what? The more qubits, the fewer errors.
Yep.
That's like defying the laws of physics, man.
It's definitely counterintuitive,
Yeah.
but that's why this is such a breakthrough.
Okay.
It's like suddenly getting better at juggling the more balls you add. That's why this Willow thing is making waves. It's showing that maybe,
Yeah.
just maybe, we're starting to figure out how to make quantum computers actually work.
I'm starting to get it.
Yeah.
But like, this other source, we have this online dude.
Okay.
He's not buying it. It's like, hold your horses.
Yeah.
Google's exaggerating.
Yeah, he's got some valid points.
Okay.
He's saying that this whole random circuit thing, while impressive, doesn't actually have any real-world use yet.
So it's like a super fast car with no steering wheel.
Haha, pretty much.
Just zooming around aimlessly in the quantum void.
He's saying it's a technical feat, but not necessarily a practical one.
Okay, I can dig that.
Yeah.
So is this all just hype then?
It's early, you know? Think of it like the first clunky computers before anyone knew what they'd be used for.
Yeah.
The potential is there, but we're still figuring out how to tap into it.
Right. It's like the potential is a wave function, dude.
Okay.
Full of possibilities, but we got to collapse it into something real.
There you go.
So this skeptical guy, he even brings up the multiverse.
He does, which is a whole other rabbit hole.
Whoa, the multiverse?
Yeah.
Like, are we saying this Willow chip is tapping into parallel universes, man?
He's suggesting that maybe, just maybe, quantum computing is a way to interact with those other realities.
Whoa.
It's a wild thought.
Dude, my brain is like a quantum computer right now.
Is it?
Full of possibilities, but mostly just generating noise.
Uh-huh.
I think I need a snack break.
I feel you. This stuff can be pretty intense.
Yeah.
But before we dive into the Doritos, let's recap what we know so far.
Okay.
Google's Willow chip is doing some impressive stuff, achieving this below threshold status.
Right.
But it's still early days.
Yeah.
This skeptical analysis raises some good points about real-world applications.
Yeah.
And the whole multiverse thing.
Right.
Well, that's a conversation for another time.
All right, snack break.
All right.
Got to fuel up for the next leg of this quantum journey.
Yeah, man. We'll be back in a bit to dive even deeper into this quantum rabbit hole. Stay tuned, listeners. Things are about to get even weirder.
Oh boy.
All right, we're back.
We're back, dude. And my brain is still buzzing from all this quantum talk.
Yeah.
It's like we're trying to grasp the ungraspable.
Yeah, you're not wrong.
You know? It's like our brains are wired for the classical world.
Yeah.
You know, cause and effect,
Right.
up and down, black and white.
Totally.
But quantum mechanics is like, nope, everything's blurry.
Yeah.
Everything's connected.
Uh-huh.
And the cat's both alive and dead until you look in the box.
Schrodinger's cat over here.
It's a whole different way of thinking, man.
Yeah, it really is.
And this Willow chip is like a tiny window into that quantum weirdness.
It is.
It's operating on principles that like totally defy our everyday experience.
Totally.
So you mentioned earlier that these qubits are like probability distributions.
Yeah.
I'm still trying to wrap my head around that.
All right.
It sounds like something out of a philosophy textbook.
Okay, let's try this.
Yeah.
Imagine a regular bit, like the ones in your phone or your laptop.
Okay.
It's either a 0 or a 1.
Yeah, I got it.
On or off.
Yeah, binary code, the language of the machine.
Exactly. But a qubit,
Yeah.
it's like this quantum rebel. It can be 0, 1,
Yeah.
or both at the same time.
Both at the same time.
Yeah, it's in this hazy state of superposition
Oh,
where
sure.
all these possibilities exist simultaneously.
Whoa, wait, so the qubit is like undecided
Yeah.
until it's forced to choose?
Kind of, yeah.
It's got commitment issues or something?
It could be.
And until you measure it,
Yeah.
you don't know what state it's in.
You don't.
It's like this fuzzy cloud of potential.
It is.
And the act of observing it collapses that cloud
Yeah.
into a definite 0 or a 1.
Exactly.
Dude, that's trippy. It's like reality itself is being created by the act of observation.
Yeah, yeah.
We're all just walking wave functions,
Candidate.
collapsing the universe into existence.
That's a good way to put it.
And because these qubits can be in these multiple states at once,
Yeah.
they can like do calculations in parallel,
Exactly.
exploring all these possibilities simultaneously.
That's the idea.
But it's like multitasking on a cosmic scale. Dude, I could barely handle checking my email and listening to music at the same time.
Right.
And these qubits are out here juggling infinite possibility.
That's the beauty of it.
And that's why they have the potential to be so powerful.
Yeah.
They can tackle problems that would take classical computers,
Yeah.
like literally longer than the universe has existed.
Possibly.
Okay, so like, let's say I have a problem I need to solve,
Okay.
right?
Yeah.
How would I actually use a quantum computer to do that?
So it's a different beast altogether.
Okay.
You're not really programming it in the traditional sense.
Okay.
It's more like you're setting up these quantum circuits.
Quantum
or-
circuit?
Which are kind of like these intricate choreographies
Yeah.
for the qubits to dance through.
So I'm directing a quantum ballet,
You got it.
and the qubits are my dancers
Yeah.
twirling and spinning through these multiple states.
Yeah, and these quantum circuits, they manipulate the qubit states,
Uh-huh.
entangling them with each other, creating these complex patterns of interference.
Gotcha.
And then at the end,
Yeah.
you measure the qubits, and that gives you the answer.
So the answer's encoded in this quantum dance.
That's the idea.
Dude, that's so much cooler than just typing code into a terminal.
It's definitely a different way of thinking about computation.
And because of this parallel processing power,
Yeah.
quantum computers can tackle problems that are simply impossible for classical computers to handle.
Exactly.
Okay, so like what kind of problems are we talking about? Can you give me some real-world examples?
Sure. One area where quantum computers are expected to have a huge impact is in drug discovery.
Oh, wow.
Imagine being able to simulate the interactions of molecules at the quantum level.
Okay.
So you could design new drugs
Yeah.
that are more effective
Yeah.
and have fewer side effects.
So like quantum computers could help us cure diseases, man.
That's the hope.
That's pretty heavy stuff.
It is, and that's just scratching the surface.
Okay.
They could also be used to develop new materials.
Optimize financial models.
Okay.
Break encryption.
Whoa.
Design more efficient solar panels.
Like quantum computers are going to change the world.
It's a big possibility.
Next industrial revolution, but on a subatomic level.
It does feel that way, doesn't it?
Yeah.
We're on the cusp of this technological revolution that could reshape every aspect of our lives.
Okay, I'm officially stoked.
Right.
But let's be real for a sec. This Google blog post, it's definitely got some hype to it.
It does.
I mean, 10 septillion years?
Right.
That's like a number so big it doesn't even make sense.
Yeah, they're definitely playing up the drama.
Okay.
But that doesn't mean it's all smoke and mirrors.
Okay, so what's the real story here? Is this Willow chip actually as groundbreaking as Google's claiming?
I think it's somewhere in between,
Okay.
you know?
Yeah.
It's definitely a significant step forward, but it's not like we're suddenly living in a quantum utopia.
Can we talk about this below threshold thing again?
Sure.
I'm still a bit fuzzy on what that means. Like a threshold of what? Reality? Sanity? Haha. So remember how we talked about noise being a big problem in quantum computing?
Yeah.
Well, below threshold basically means that the error rate is low enough that you can actually start building larger and more complex quantum computers.
Okay, so it's like before, we were just messing around with these tiny quantum computers that were super prone to errors.
Right.
But now with Willow, we're like entering a new era.
It seems that way.
Where we can actually start building these machines that can do real work.
Yeah, it's like we finally crossed this critical threshold where the technology actually starts to become practical.
I'm getting it now. What's next?
Oh, yeah.
What are the big challenges that quantum computing still needs to overcome?
Well, one of the biggest challenges is scalability.
Scalability.
Right now, we're still working with relatively small quantum computers with a limited number of qubits. To really unlock the full potential of this technology, we need to figure out how to build machines with thousands or even millions of qubits.
Millions of qubits? That's like a quantum metropolis, dude.
It is.
How do you even build something like that?
That's the million-dollar question, literally.
Yeah.
It's a massive engineering challenge.
Yeah.
It's like trying to build a skyscraper out of grains of sand.
Dude, that's an awesome analogy.
So let's say we do manage to build these massive quantum computers.
Yeah, let's say we do.
What then? What are the big picture implications that we need to be thinking about?
Yeah, what happens then?
That's where things get really interesting.
Oh boy.
Because quantum computers have the potential to be incredibly powerful.
Okay.
And with great power comes great responsibility.
Totally. It's like with great quantum power comes great quantum responsibility.
Exactly.
We gotta be careful not to unleash some kind of quantum apocalypse.
Haha. Yeah. So one of the big concerns is privacy. Quantum computers could potentially crack the encryption that we use to protect our online data.
Yeah.
Which could have huge implications for security and privacy.
So quantum computers could be used for evil purposes.
It's possible.
Like some supervillain could use them to hack into the government? Or steal everyone's Bitcoin?
It's not impossible.
Oh, man.
Just like any powerful technology, it could be used for good or for bad.
Right.
That's why it's so important to start thinking about these ethical and societal implications now, before it's too late.
Okay, that's deep, man. I'm starting to feel the weight of quantum responsibility on my shoulders.
I hear you.
It's like the future of humanity is hanging in the balance of these tiny little qubits.
It is a lot to process for sure.
Dude, I need another snack break.
All right, let's take 5.
This stuff is making my brain hurt.
We'll be back in a bit to explore the even weirder side of quantum mechanics.
Okay.
The multiverse. Stay tuned, listeners. Things are about to get really meta.
Okay, dude, we're back. And my brain is still swirling from all this quantum talk. It's like my thoughts are entangled now. Superpositioned and uncertain.
Quantum mechanics. It's like the ultimate mind trip. Staring into the abyss and seeing infinity reflected back at you.
Infinity, man. That's heavy. But before we get lost in the void, let's circle back to that skeptical dude's analysis. He was like, whoa, there, Google, don't get too excited. What was his problem with the Willow hype?
He was basically saying that this whole 10 septillion years thing is misleading. Yeah, it's impressive that Willow can do these random circuits and stuff so fast, but so what? What does that do for us right now? He's comparing it to a kid messing around with a circuit board, making LEDs blink randomly. It's cool, but is it revolutionary? Not really.
So it's like Willow is a super fast race car, but we haven't built the racetrack yet. Just burning rubber in the quantum garage.
Pretty much. And he also pointed out that the problem Google tackled with Willow, this random circuit sampling thing, it's kind of rigged in favor of a quantum computer.
Right. It's like testing a fish by how well it swims.
Exactly.
Of course it's going to do great at that.
Yeah. So how do we know Willow is actually doing something groundbreaking and not just solving a problem that we made up for it to solve?
Right. How do we know this isn't just a fancy quantum parlor trick?
That's the million-dollar question. And honestly, we won't really know until we see what these quantum computers can do outside of these controlled lab settings. Can they tackle real-world problems in fields like medicine materials, science, or AI? That's the real test.
So we gotta wait and see. But dude, even if this whole thing is just hype, thinking about the possibilities is still mind-blowing. The potential of this technology is just, whoa.
Absolutely. Even if we never achieve full-blown quantum computing, just the journey of exploring these ideas, is pushing the boundaries of human knowledge.
Totally. It's like expanding our consciousness, thinking about all these different possibilities, parallel universes, this interconnectedness at the quantum level. It's like we're starting to see the universe in a whole new way.
We're zooming out and realizing how much we don't know, and that's like the most exciting part of science, right? The mysteries are more mind-blowing than the answers sometimes.
Dude, I'm officially mind blown.
Sure.
So for our listeners who are probably feeling the same way, what's the TLDR of all this quantum craziness?
All right, so here's the deal. Google's Willow chip is a big step forward in quantum computing. But it's not about to change the world overnight. There's still a ton of work to be done, both in terms of developing the technology and figuring out how to use it responsibly.
Right. It's like the seeds have been planted. But we got to be patient and see what grows. Maybe it'll be a beautiful quantum tree. Or maybe it'll just be a weird quantum weed.
Exactly. But even in these early stages, quantum computing is forcing us to confront some of the biggest questions about the nature of reality, the limits of knowledge, and the potential of technology. And that's pretty awesome.
Totally awesome. All right, dude, I think that about wraps it up for our deep dive into quantum computing. We covered everything from the technical details of Google's Willow chip to the mind-bending implications of the multiverse. It's been a wild ride.
It has been a trip.
Totally a trip. So to our listeners, we leave you with this. Go do some of your own research. Explore the weird world of quantum mechanics. And let your mind be blown. Peace out.